Okay, so today we're going to finish up 4.2 binomial probability, and we're going to start off by looking at binomial probability distributions. So remember our formula for binomial probability was P of x equals n combination x times p to the x power times q to the n minus x power. Remember, n was the number of trials, x was the number of successful trials, p is the probability of success, and q is the probability of failure. So if we look at a survey of United States adults that were asked to identify which social media platforms they use, the results show that 62% of those use Facebook. 6 adults who participate in the survey are randomly selected and asked whether they use the social media platform Facebook. Construct a binomial distribution for the probability of adults who respond yes. So identify n, p, q, and x. So our n value would be these 6 adults. P is our probability of success, which would be 0.62. Q would be 1 minus 0.62, which equals 0.38. And then our x value is going to be from 0 all the way up to 6. Okay. So now we're going to make a probability distribution using the binomial probability formula. So we're going to make our table. X and P of X. Our X values 0, 1, 2, 3, 4, 5, and 6. And then we're going to plug into our formula. Okay. So the probability of 0 would be 6 combination 0 times 0.62 to the 0 power. Oops. Times 0.38 to the 6 minus 0 power. Okay, if we simplify that and plug it into our calculator, remember for probability, we're going to round to 3 decimal places. We get 0.003. Okay. Let's set up the second one. So we're going to have 6 combination 1 times 0.62 to the first power times 0.38 to the 6 minus 1 power, or you can write 5, either way. So go ahead and find that probability. You should get 0.029. Okay, so now I want you to go ahead and find each of the following probabilities, 2 through 6, and complete the table. Okay, so now that your table is completed, we want to check, make sure that all of your probabilities are between 0 and 1, which they are. And now also we want to check that the sum of the probabilities equals 1. So if we add up all of our probabilities, what do we get? Okay, and we do get 1, so this checks. So that is our discrete probability distribution. So now we can find probabilities using those formulas. So from the previous example, find the probability that exactly 2 say yes. So the probability of 2 equals, I'm going to slide back up to our table. The probability of 2 would be the 0.120. Okay. The probability of at least 2 would be x is greater than or equal to 2, which means we're going to be doing 2 plus 3 plus 4 plus 5 plus 6. Or if you wanted, you could do 1 minus the probability of 0 and 1. So whichever one you prefer, I want you to go ahead and try this. And you should get 0.968. All right, then the probability that fewer than 2 respond would be x is less than 2. Well, less than 2 would be 0 and 1. Well, that's the complement of our answer for example 2. So we can do 1 minus 0.968, which gives us 0.032. All right, so we also have a binomial probability table, okay? And that is in your booklet that I gave you. So about 10% of workers 16 and over in the United States commute to their jobs by carpooling. You randomly select 8 workers. What is the probability that exactly 4 of them carpool to work? Use the table to find the probability. So first off, let's find our probability of success. So our p-value is 10%, so 0.10. And then we need to find our value of n, which is 8. Okay, so now we're going to take a look at the table. Okay, so looking at your tables, so we're going to go to page A8. Oops. And looking for table 2. Okay, so binomial distribution table. So remember our n value was 8, so I'm going to slide to 8. And then our p-value was 0.1. Okay, so I'm going to go ahead and highlight that table. Okay, so looking at this, we want to find the probability of exactly 4. So if x equals 4, oops, our probability is just 0.005. You can use the formula we've been using, but that's a little bit more work. The nice thing is you can just use this table and it'll get straight for you. Okay, if it asks you for the probability that x is less than 2, we know that's the probability of 0 and 1. So we could just add these two probabilities together rather than doing the formula over and over again. Okay. The hard part about this is, so the table is wonderful, but let's look at our probability of successes. They're all nice numbers. Okay, they're all going by increments of 5, other than our very first one of 0.01. Okay, so if we have a probability of success of 0.67, that's not in our table, so we would have to do that by hand. Okay. All right, so let's go back to our notes. Okay, we found that the probability of 4 from the table was 0.005. So for graphing a binomial distribution, we're just going to use a histogram. Okay, we're just going to use a histogram. All right, last thing. Mean, variance, and standard deviation. We can use the table format the way we have been with Google Sheets or by hand, either way, but it does take a lot of work. What's nice with binomial distribution is we can shorten it. Okay, so our formula for a mean of a binomial distribution is just n times p. Our variance, so sigma squared, equals n times p times q. And the standard deviation we know is the square root of the variance. So the square root of n times p times q. Okay. All right. So if we look at this first example, in Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. Find the mean, the variance, and the standard deviation. We're not going to worry about interpreting the results right now. Okay. So we know our probability of success of a rainy day is 0.56, which means that our probability of it not raining would be 0.44. And then our n value, so the number of days in June, is 30. So for our mean, we're doing n times p. So we're taking 30 times 0.56. Plug that in your calculator. And if we round to one more than our x value, which here would just be our whole numbers, we get 16.8. Okay. Our variance, we're going to do n times p times q. So 30 times 0.56 times 0.44. And again, round to one more decimal place than our original. And we get 7.4. And then our standard deviation, remember, we want to make sure we take the square root of our original, so unrounded. So we're taking the square root of 30 times 0.56 times 0.44. And if we do that, we get 2.7. Okay. All right. I want you to go ahead and try this second example about California during the month of May. And just in case you don't know, May has 31 days. So find your p-value, your q value, and then go ahead and find your mean, your variance, and your standard deviation.